Hey everybody, I'm not there with you physically this week, but I'm going to record a few of these to talk you through the topic of the week, which is electric circuits. Electric circuits are something some of you may have seen a lot of before, and some of you may have seen none of before. So as we do in class, I'll just kind of talk you through the basics, and we'll work through some examples, so hopefully everybody gets to a certain level of comfort with them. Uh, Again, some of you will have seen this before, but jumping right in, we draw circuits with this crazy circuit notation or schematic, sometimes it's called. Uh, Little things you'll have to get comfortable with is this crazy looking thing over here, these parallel lines. They won't always be labeled with that little positive and little negative, but that symbol there, here I'll draw another one, a symbol that kind of looks like this, two parallel lines. That's the symbol for a battery or a direct current power source. Deeper into it, the little side of it, the chemistry of whatever's going in the battery, the side that we draw as the little side ends up being the negative terminal, and the side drawn as the bigger side is the positive terminal. This one that I literally just found online, it has an arrow indicating the direction of the current. Current has got sort of two forms. Way back when Benjamin Franklin and those guys were flying kites and lightning storms, they always imagined positives were moving. So sometimes that gets labeled as conventional current, just out of respect for those guys that did it early days. We picture positives as moving around a circuit. Nowadays, now that chemistry's got better, we know that it's electrons that are wee, tiny, and light, and electrons move around the circuit. So this particular one on the left, this one that I grabbed, those arrows are showing the negative flow. Basically, opposites always attract. So any negatives that were in the wire would repel away from the little side. So when they show a current leaving the little side of the battery, that's always going to be a negative flow current. Negatives would get repelled away from that negative terminal of the battery. If Benjamin Franklin were still alive, those folks would kind of look at the battery and they always pictured positive flow. So they might look at the same circuit and draw an arrow leaving the big side of the battery representing the positive flow. The weird thing is for circuits is it doesn't really matter. Whatever the circuit is, these are one or two or three things. If they're light bulbs, they're still going to light up, whether we imagine positive flow or negative flow. So there are two kinds of circuits, two kinds of way to think about current. Positive flow would leave the big side of the battery. So for this particular one, kind of loop around clockwise. Or we could picture the exact same circuit and imagine negative flow. Negative flow leaves the little side of the battery. For this one, it would go around counterclockwise. The battery is going to be communicated in terms of voltage, and the voltage we'll talk more about when we do examples. The voltage is how hard the electrons get pushed around the circuit. So it's kind of connected to energy, how hard they're pushed. In our circuit diagrams, this crazy symbol, this is zigzaggedy line here. Here, I'll draw another one over here. That's a generic symbol for a resistor, or it's come to mean any sort of electrical load. Maybe it's a light bulb, maybe it's a little motor, maybe it's like the screen on your cell phone. Anything that uses up electrical power, we can draw with that generic squiggly line thing. It could literally be a resistor, or it could be an actual device, just for simplicity. There are other symbols for light bulbs and things, but often we just draw them as those resistors, those bumpy line things. This one over here, the same thing. A battery up top, three resistors kind of in the middle. If we were to picture negative flow, the negatives would leave this side of the battery and loop around going counterclockwise. When they get down to here, the current would have to make a choice. Some would go up and that way, some would go straight through, some would go down, but we'll talk about that more in a little bit. Big picture, this kind of circuit, the one I've got, the way I've picked them, the one I've got on the left, this one I'm going to call a series circuit. We'll talk more about them, but that basically means the electricity doesn't have a choice. It's got to go through each of the resistors. There's no branches, no variety in the pathway, as opposed to this one over here that I'm going to call a parallel circuit. This is the one where the electricity kind of has a choice. If we picture negative flow, when the negative flow got to this point, some of the electricity will go straight through, some of the electricity will go up, some of the electricity will go down. That's a good spot to pause this video, just a little bit on notation.